Imagine a state-of-the-art robot. You give it a simple command: bring me the book that's on the coffee table. But the book is upside down. The robot might freeze or place its gripper on the spine, unable to grasp it. It fails not because it can't see the book, but because its model of book lacks a fundamental, unwritten rule. Books are typically picked up by their covers. This isn't a rule you learned, it's knowledge you absorbed by living. This gap is where the grand project of artificial intelligence currently stumbles. It's the chasm of implicit knowledge. Think about the sheer volume of things you know without knowing how you know them. You know that you can't push a rope. You know that a glass filled with milk is heavier than an empty one. This isn't data you downloaded, it's physics you learned with your hands. This is the essence of embodied cognition, the theory that our minds are not separate from our bodies, but are deeply shaped by our physical interactions with the world. An AI, existing as pure code, has no body. It has no hands to learn the simple truth of a rope. AI developers are creating what they call world models. These models learn, for instance, that pictures of cats often contain whiskers and pointy ears. They build a statistical map of reality. But your world model is different. It's not just statistical, it's causal. You know that if you push a tower of blocks, it will fall. You know this because you have an internal, intuitive physics engine, one that began calibrating the moment you first dropped a toy from your high chair. AI has to infer these physics from trillions of pixels, a bit like trying to understand gravity by only looking at still photographs of apples. This physical grounding runs deeper than you might think. It infects our most abstract thoughts. Consider the phrase, "a heavy topic." Why heavy? Or grasping a concept. We use physical metaphors constantly. Linguists argue that our entire system of abstract thought is built on metaphors, rooted in our physical experience. We map abstract ideas onto concrete domains like space, motion, and force. An AI that has never experienced physical force or occupied a physical space might be able to manipulate the words heavy and grasp, but does it truly understand the concepts they represent? This leads to a classic philosophical hurdle in AI called the frame problem. If you ask an AI to get you a glass of water, it theoretically has to consider every possible side effect. Will picking up the glass alter the air pressure in the room, causing a hurricane in Brazil? Will the Earth's rotation be infinitesimally affected? You, a human, instinctively know what's relevant. You frame the problem, ignoring a near infinite list of absurd possibilities. This ability to discern the relevant from the irrelevant without conscious effort is a cornerstone of common sense. It's what stops your own mind from getting lost in a computational storm every time you make a decision. So, when we talk about creating an artificial general intelligence, what are we really aiming for? Are we building a mind, or are we building a spectacularly complex pattern-matching machine? A disembodied intelligence, trained on the Internet's reflection of the world, might never develop the kind of common sense we take for granted. Its intelligence will be alien, built on a foundation of correlation, not causation, of data, not experience. And perhaps the greatest puzzle is not whether a machine can think, but whether a mind that has never felt the weight of a book can ever truly understand what it means to hold one. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.